Welcome back to our series on AI audit exam prep. In this session, we are diving deep into the business considerations and governance of AI solutions. We will explore how organizations justify investing in these technologies, how they weigh the costs against the benefits, and the critical decisions they must make regarding hosting, vendors, and shared responsibilities. Beyond passing your exam, understanding these concepts is vital for your day-to-day professional life. You will be able to confidently evaluate whether a proposed AI tool makes financial and operational sense for your specific workplace before any contracts are signed or data is shared. Whenever an organization decides to bring an AI solution into their environment, they must rely on an established change management process. A change management process is simply the formal, structured way a company introduces any new technology or workflow to avoid disrupting daily operations. You should not treat the implementation of an AI tool any differently than you would treat the rollout of a standard email platform or accounting software. The fundamental steps remain the same. However, the way you handle the tool after it is implemented is where things change, because AI introduces highly unique operational and risk factors that traditional software does not. Every proposed AI project must start with a thoroughly documented business case. Think of a business case as a persuasive essay designed to justify spending time and money on a project. To be effective, this document must clearly outline several critical elements. First, it must state the exact problem the AI is supposed to solve. Second, it needs to explain exactly how the technology will solve that problem. Third, it must include a comprehensive financial breakdown of the expected costs versus the anticipated financial returns. Fourth, the document must identify potential hazards and how the organization plans to mitigate them. Finally, it requires a step-by-step plan for how the tool will be deployed. Documenting these elements ensures that technology is chosen on purpose, not just because it is popular. It is very easy to get swept up in the excitement of new technology. But if you adopt a tool without a clear, specific need, the project is highly likely to fail. Imagine buying a massive commercial tractor for a small rooftop garden just because the tractor was on sale. It is an impressive machine, but it completely fails to match the actual environment and need. The very first step is identifying that core problem. Companies usually find these problems by forming internal groups, like an innovation steering committee, by directly asking their employees where they struggle, or by bringing in outside consultants. Often, the problems revolve around slow operational speeds or the need to cut down on human mistakes. Once the problem is clearly defined, the search for a matching AI solution can begin. During this search, an organization has to look at how mature and proven the technology is. Industry experts often track technologies on a lifecycle curve that measures how hyped a technology is compared to its actual practical usefulness. When assessing risk, you must look at where a proposed tool sits on that curve. If you choose a well-established, standard cloud-based service, like a common automated text translation tool, the path to success is very predictable. The costs are clear, and the benefits are proven. On the other hand, if a company decides to build a brand new, highly experimental neural network from scratch, they are taking on a massive amount of uncertainty. There is no clear roadmap for how that experimental project will actually become a functional, profitable reality. Once solutions are identified, it is time for the cost-benefit analysis. While many software costs are standard, AI brings unique expenses. Implementation costs include building the system, buying licenses, and spending hours training staff on how to use the new prompts. Operational costs are ongoing. You have to pay for system maintenance, massive amounts of electricity to run the computer processors, and the high salaries of specialized data scientists. Then there are risk and compliance costs, which involves spending money to protect user privacy and managing the company's public reputation if the system makes a high-profile mistake. These costs have to be weighed against the expected benefits, which must directly link back to that original problem we discussed earlier. The main benefits usually fall into three buckets. The first is efficiency and automation, which means having the machine handle boring, repetitive chores so human workers can focus on creative or high-value thinking. The second is improved decision-making, allowing leaders to make choices based on massive oceans of data rather than gut feelings. The third is direct cost reduction, which simply means spending less money on manual labour and fixing preventable errors. When we talk about the financial return on these investments, recent industry surveys show very positive trends. Roughly 3/4 of surveyed business leaders report seeing a positive financial return from generative tools. Even better, over 80% of them managed to get their systems fully operational within just 6 months. For those tracking revenue growth directly tied to the new technology, a vast majority saw their overall annual revenue increase by 6% or more. However, you must set realistic expectations. In the early days of a new project, the financial return might look terrible. This is because the upfront costs are incredibly high, and employees are still awkwardly learning how to use the system, which temporarily slows them down. Think of it like installing solar panels on your house. The day you install them, you are in a deep financial hole. But over time, the utility bills vanish and the investment pays off. Also, keep in mind that not all returns are strictly financial. You must also measure human factors, such as whether your employees are less stressed or if your customers are having a more pleasant experience. Next, a company must decide where the physical brain of their AI will live. They can host it internally on their own physical property, or they can rent space in the cloud. Hosting internally provides ultimate control. You can customize everything, optimize the machinery for your exact tasks, and easily lock down data security because the information never leaves your building. But the downside is severe. You are limited by the hardware you own. Your electricity bills will skyrocket, and you have to hire brilliant technicians to keep the servers running. Alternatively, cloud hosting means renting computer power from a massive tech provider over the internet. The benefits here are massive flexibility and scalability. If you suddenly need 10 times the processing power, you just click a button to upgrade your subscription. Your initial costs are tiny, and you do not have to fix broken hardware. But cloud hosting has serious limitations. You lose control over the physical environment, and you face vendor lock-in. Vendor lock-in means your systems become so dependent on a specific provider that switching to a competitor becomes financially impossible. You also face network latency, which is a tiny, frustrating delay as data travels from their servers to your office. Most importantly, your sensitive data is leaving your controlled fortress. If you choose the cloud, the physical geographic location of those external servers becomes a massive compliance issue. Many international privacy laws dictate exactly where citizen data can and cannot travel. Therefore, whoever oversees these third-party relationships must make sure the vendor is keeping the data secure and aligning with the company's grand strategic vision. When bringing in outside vendors, the vetting process is critical. It starts with standard procurement steps to assess the general contract risks. But for these advanced systems, the assessment must dig deeper. You have to verify that the vendor shares your organization's ethical values. You must ensure their systems have explainability. Explainability simply means that when the computer makes a decision, a human can look under the hood and understand exactly how and why it arrived at that conclusion. Without explainability, you are blindly trusting a black box. Naturally, you must also deeply audit their privacy and security protocols. Once a vendor is hired, the relationship requires constant babysitting. The company must establish clear service level agreements, or SLAs, which are legally binding promises about how fast and reliable the system will be. These agreements must be reviewed regularly based on the risk level. The people doing the reviewing must thoroughly understand their own company's technological goals so they know what red flags to look for. This ongoing vendor performance data is a crucial part of recalculating that financial return on investment over time. If an organization lacks the genius programmers to build custom tools, they will often buy off-the-shelf solutions. These are pre-built, ready-to-use applications provided by an outside company. They are fantastic for speed, but they introduce a dangerous blurring of boundaries. When things go wrong, who is to blame? There are 3 major risks here. First is accountability. If no one explicitly writes down who is supposed to maintain the system, it will break and compliance will fail. Second, are ethical concerns. If a pre-built algorithm denies a customer a loan based on an unfair bias, there will be massive confusion over whether the vendor who built the tool or the bank who bought it is legally responsible. Third is data security. Sharing your private data with another company creates more attack vectors, which are basically new, unprotected doors that hackers can try to open. Let me be perfectly clear. The ultimate responsibility for defining who does what lies entirely with the organization purchasing the tool. Your people and your procedures are the ones feeding data into the machine, so you must establish the boundaries. You need a framework that strictly defines what tasks belong to you, what tasks belong to the vendor, and where the tasks overlap in a shared capacity. The industry standard for this is the shared responsibility model. Imagine hiring a company for a large catered event. If you just rent their empty kitchen, which is known as infrastructure as a service, you are entirely responsible for bringing the ingredients and cooking the food safely. If you rent the kitchen and use their basic prep staff, known as platform as a service, the responsibility is shared. But if you hire them to provide fully prepared, ready-to-eat meals, known as software as a service, they handle the heavy lifting of cooking. However, even in that final scenario, you are still the one responsible for checking IDs at the door and making sure the guests behave. In the digital world, that means you are always responsible for user training, access controls, and governing your own data, no matter how much of the underlying tech is handled by the vendor. All of this brings us to part B, which is governance and program management. Governance simply refers to the rules, standards, and guardrails a company puts in place to guarantee that their advanced tools are used safely and ethically. Think of governance like traffic laws. The laws do not exist to prevent you from driving. They exist to create predictable lanes and speed limits so everyone can reach their destination quickly without crashing. Many companies try to force these new tools into their old, traditional IT governance frameworks. While this works as a starting point, it is usually not enough. Intelligent systems behave unpredictably and learn over time, which breaks the mold of traditional, rigid software. A strong governance program follows a specific life cycle. First, leadership must define the grand strategy. Then, they assign concrete roles and responsibilities to specific humans. Next, they write formal policies and procedures to guide those humans. Those written documents are useless without formal training and awareness campaigns to ensure the staff actually understands them. Finally, the entire program must be measurable. You have to track specific metrics and report those numbers back to an oversight board to prove the guardrails are actually working. Let us recap what we covered today. We learned that adopting new intelligent tools requires a solid business case with a clear problem, a realistic cost-benefit analysis, and a strategy for managing long-term change. We explored the heavy trade-offs between hosting systems internally versus renting space in the cloud. We discussed the absolute necessity of vetting third-party providers for ethical alignment and security. We broke down the shared responsibility model so you know exactly who is legally on the hook when things go wrong. And finally, we looked at how governance provides the crucial guardrails to keep the entire operation safe and measurable. To make sure these concepts are locked in for your exam, you need to practice them. All the important topics and concepts from this session are covered in the multiple choice questions on roocloud.com. You should ideally solve the chapter-wise questions to reinforce your learning before moving on to the next session. Thank you for listening, and I will see you in the next video.